Hello everyone, today's topic is hydrates, and that's kind of related to the lab you just have finished. And let's first introduce you to the concept of hydrates. And what we refer here, the hydrates, it's strictly restricted to what we call it inorganic chemistry. And in organic chemistry, you encounter another kind of hydrates, but it's quite different. And those are defined as the inorganic salts containing water molecules combined in a definite ratio as an integral part of the salt crystal that are either bound to a metal center or that have crystallized with metal complex. The origin of the hydrate has a lot to do where those solid of inorganic salt coming from. They generally coming from crystallization from aqueous solutions, and a lot of times happening in ancient oceans. So when the inorganic compound start to crystallize, generally they start to incorporate some of the water into its crystalline structure, as we stated here, either by the direct interaction with the metal center or be trapped. It will be trapped water inside the cavities of those latter structures. Well, one of the examples is shown here, and what is the blue one? This is actually cobalt 2 chloride. This is actually cobalt 2 chloride, and it does not contain any water, and now you have a bluish color. But when the water is attached to this compound, and it actually turns into a vibrant magenta color, the reddish color. So this is actually hydrate. Each of the hydrate formula unit, cobalt 2 chloride, in this case is COCl2, is associated with 6 water. There's some kind of conventional names for those. Cobalt 2 chloride without the water is called anhydride. Then anhydride, or sometimes also referred to as anhydrate. And in this case, the prefix means no water. And this water is sometimes also referred to as water of hydrate or water crystallization. And as you can see, there's a very specific number associated with the water molecules incorporated into each unit of this anhydrate. So, and we gotta come up with a system to name the hydrate, and also is from the names to the formula, formula to the names. What the system entails is as we said before, hydrates actually composed of two parts. Hydrates composed of two parts. One part is the anhydrate. It is generally inorganic salt. So you have the name for those, and you have this conventional have a dot indicating they are linked, but it's kind of separate. So then now you have H2O molecules associated with it, and we use the prefix to indicate the number of water molecules associated with hydrate. So if it's one water molecule, that will be mono, 2 will be di, 3 would be tri, 4 will be tetra, 5 will be penta, 6 will be hexa, 7 will be hepta, 8 will be octa, 9 will be nona, 10 will be deca. And actually the list goes on, but generally we stop at 10 for those common hydrates. And give you an example, just use the one we saw on the previous slides, and that particular, the blue anhydride will be cobalt 2 chloride, and now you'll have 6 water associated with each formula unit of that. So in this case, the name for this compound will be cobalt 2 chloride. It's the name of this hydrates. And now you'll have 6 will be hexa hydrate. Will be hexa hydrate. Okay, let's kind of pause here on the slides. Let's fill in the blanks. If you see the formula, give the proper name for it, and if you see the name, translate that into formula for the hydrates. And you should pause the video right now and get a sheet of paper out, work on those problems, and then you can check on the answer on the next slide. Hopefully you got all of them right, and now we can actually move on beyond the names and the formula of the hydrates. So, and if we looking at this, and a very important one, as you did in your lab, is how to figure out the hydrate formula, and how to figure out the hydrate formula. And as you can notice that, and recall the hydrate is composed of 2 parts. Is the first part will be the anhydrate, and the second part will be the X of water. And as you can see, the X indicating how many water molecules associated with each formula unit of the anhydrate. So this is actually, we're going to see very similar concept with the empirical formula. Okay, it's very similar and very parallel. If we can actually figure out the number ratio between anhydrate and water. So if we can get that simplest integer ratio, so then we can actually easily to rewrite the hydrate formula. As we can also know from the empirical formula, the number ratio is equal to the mole ratio. Okay, so if we can figure out the mole ratio between the hydrate and the water, you can readily write the hydrate formula. So then coming down to the process. So step number 1, figure out mass for an hydrate and the water, in this case water of crystallization, or sometimes referred to as water of hydration respectively. Step number 2, convert mass into moles of hydrate and water respectively. Step number 3, take the mole ratio of anhydrate and water. Find the simplest set of integers. Step 4, write the hydrate formula based on mole ratio. Okay, so then those steps, if you've taken it, you can solve pretty much all kinds of questions involving hydrates, and apply that when you're trying to wrap up your lab report. And let's take a look at kind of example to show you the detail how the procedure works. You can see here, you will know by reading this, you can see the anhydrate is calcium chloride, and the total mass of the hydrate will be 4.72 grams. And after heating for several minutes, the mass of the anhydrate found to be 3.56 grams. And you have to use this information to actually determine the formula for hydrate and then subsequently actually name it. So as we can see here, the total mass of hydrate is 4.72 grams, is actually equal to the mass of anhydrate. According to this problem, it will be 3.56 grams plus mass of water. Okay, that will be in grams. So hence mass of water will equal to 4.72 grams minus 3.56 grams. Punching the calculator, 1.16 grams. So in this case now, we have 4.72 grams of calcium chloride, and you want to go to the mole of calcium chloride, and now I have to go to the gram of calcium chloride. As you can recall, this is a classic example of a molar mass. 1 gram or 1 mole of calcium chloride will equal to approximately 111 grams of calcium chloride. How do you get that? You can see, look at the sidebar. Calcium, you have 1, chlorine, you have 2. Molar mass for calcium is 40 grams per mole. You get that from the periodic table. For chlorine is 35.5 grams per mole. So you multiply this, you got 40, you got 71 added together. That's where the 111 grams coming from per mole. You use that, cancel the unit, you can get the mole, so you can have that, punching the calculator, and just simply realize that, and now you see the mistake I made here is actually the amount of the anhydrate is not 4.72, the amount should be 3.56. okay, So that is a good lesson. You can learn it. It's got to be very careful to distinguish which is anhydrate, which is actually water for the mass. So now you can actually punch in a calculator to get the correct number of moles of the anhydrate will be 0.0321 moles of calcium chloride. Very straightforward. The amount of the water in terms of mass, 1.16 grams of water. Want to convert it to mole of water, and have to go through the molar mass of water. 1 oxygen 16 and 2 hydrogen, each one is 1, and 1 mole of water is equivalent to 18 grams of water. Punching the calculator, unit cancels, okay, which you want, 0.0644 mole of water. So now the step is trying to get the mole ratio, CaCl2, the mole H2O. You're going to have, copy the number, 0.0321 over 0.0644. Take the smallest number and divide each one by 0.0321 divided by 0.0321. That will be the ratio, 0.0644, 0.0321, and now you can simplify that. It's 1 to 2. That is the ratio. So the formula for the hydrates will be 2H2O, 1 of the formula unit, calcium chloride, 2 water. Actually, the official name for this will be calcium chloride dihydrate. Di means 2. Di means 2. So let's take a look at 3 problems are posted here, and those are very common problems involving calculation of hydrates. Trying to apply the knowledge you just gained, the process. Go through the process of determine the mole ratio of the anhydrate and water, and you can get that, and now you can get the hydrate formula, and from that you can actually get the name of the hydrate. Pause your video now, get a piece of paper, work out detailed solutions for those 3 problems, and then you can compare the answers on the next slide. And with this, I conclude this vlogcast on the hydrates. Thank you very much for your attention.